All right, congratulations. You guys have made it to notes number 11, which is the last set of notes in this unit. And it's a pretty easy way to end proportional and non-proportional situations. You guys just need to show me that you can distinguish between proportional and non-proportional. First, we're going to do it using a graph, which is the easiest way to do this. Just a quick reminder, if a relationship is non-linear, so non-linear means not a straight line. So if your graph was like this, and it was something curved, or even if it was something that zigzagged like a stock market, that would be nonlinear, and therefore it's automatically non-proportional. So if you have a nonlinear graph, it's already non-proportional. If it is linear, quick reminder, if it is linear, so if it is a straight line, it may either be proportional, which means it goes through the origin, which means its y-intercept would be 0, 0. Or it may be non-proportional. So it could be linear, a straight line, but just not going through the origin. So it may be either proportional or non-proportional if it is linear. When the graph of a linear relationship contains the origin, so that means it goes through the origin, that's when it's proportional. All right, let's look at our example. The graph shows the sales tax charged based on the amount spent at a video game store in a particular city. Does the graph show a linear relationship? So that's pretty easy. Remember, the word linear has the first 4 letters that spell out the word line. So is this a straight line? Yes, it is. Is the relationship proportional or non-proportional? Does it go through the 0, 0, the origin? And yes, this one does. So that makes it proportional. All right, real quick, you guys should be able to glance at these next two and do them super fast. First one, linear and non-proportional, because it does not contain the origin. Second one, linear, it's another straight line, but this one does go through the origin, so this one is proportional. All right, now we're going to distinguish between proportional and non-proportional using an equation. This is not quite as easy, but it's close. It's not bad. All right, this is how to distinguish it using an equation. If the equation is nonlinear, again, it represents a non-proportional. So first of all, if it's nonlinear, it's going to also be non-proportional. But again, if it is linear, if it's in the form y equals mx plus b, it may only represent proportional if b is 0. Or it'd be non-proportional if b is anything else. So if b is not 0. So for example, if b is 2 or -7 or 1/2 or anything, if it's anything besides 0, it is non-proportional. It has to be 0 to be proportional. So here's our example. The number of years since Keith graduated from middle school can be represented by the equation y equals a minus 14, where y is the number of years and a is his age. Is the relationship between number of years since Keith graduated and his age proportional or non-proportional? All right, let me write this above it just so you remember. Y equals mx plus b. The plus b has to be 0 for it to be proportional. It has to be able to go through the origin. If it starts at any other number, it's non-proportional. So here's our y equals, a is going to be, I'm not sure if that's either our slope or our x, it doesn't matter. But then you have minus 14 here. Minus 14 tells me that the y-intercept would be at -14 on the graph, not at 0, 0. So this is a linear relationship, but it is non-proportional. Remember, if anything else in this situation is any number, it's non-proportional. It would have to be 0, which in most cases, if it was 0, it wouldn't even be there at all. It would have just said y equals a. But a minus 14 means non-proportional. Okay, your turn. Determine if the following 4 examples represent proportional or non-proportional relationships. Push pause on the video and give it a try. Okay, something important to notice is these are not Y's and X's. These are different random letters, but that's okay. As long as you have something in the place of the Y and in the place of the X, you can just pretend it's X and Y. So again, I'm going to write this equation, y equals mx plus b, just so that we understand what it should look like. And the b part has to either be not there at all, or it has to be a 0 in order for it to be proportional. So this would be y equals 65x. And if it doesn't say a b plus or minus nothing afterwards, then that means it is proportional, because it would go through the 0, 0, the origin. All right. This one, y equals, and I kind of like that they flip-flopped it on you. Normally the number with the letter would come first, like y equals mx, and then plus your b, but these has it reversed, and I kind of like that. This would be the same thing as saying n equals negative 3p, and that's a positive 450, so plus 450. And if we made that y equals, and then instead of p, x, this is what our equation would look like. So y equals negative 3x plus 450. This is not 0. So since it's a number, it's non-proportional. All right. This one is already in y equals mx plus b form. But look at our b. It's not 0, so therefore it's non-proportional. All right, and then the last one, it's kind of, I'm actually going to need to divide both sides by 12 to get d by itself, which I assume is what they're thinking our y is. So I'm going to divide both sides by 12 real quick. And I have d equals 3. Or I can write it this way if you'd rather. And that's kind of like saying y equals 3. So there's no x, but that actually means that it is going to be, this is a little bit of an advanced question. You can even star it. If we were to graph this on a line, it would actually be a y-intercept of 3, and it would be horizontal. So in this situation, we have no, we do not have it going through the origin. So since there's no x, this is our b. So it doesn't have a slope, but it does have a b, a y-intercept. So this one, since it does not contain the origin, and the b is a 3, it is also non-proportional. All right, good job. Let's go to the next page. Okay, we are now going to distinguish between proportional and non-proportional situations using a table. All right, so here's our table. If there is not a constant rate of change in the data displayed in the table, then the table is nonlinear and non-proportional. So nonlinear and non-proportional if there is not a constant rate of change. Okay guys, my computer just did something weird, so sorry if I'm jumping ahead or reviewing something that I've already said, but I am on the second page of notes today, and we are now distinguishing between proportional and non-proportional situations using a table. The only thing I had said, I'm not sure if the video caught this or not, is that if it's not a constant rate of change, then it is nonlinear and non-proportional. So we are looking here for a constant rate of change. All right, a linear relationship represented by a table is a proportional relationship when the quotient of each pair of numbers is constant. And I'll go over exactly what I mean by that in just a minute. Otherwise, the relationship could still be constant, but it will end up being non-proportional. All right, here's our example. The values in the table represent the number of US dollars 3 tourists traded for Mexican pesos. The relationship is linear, so it's telling us already it's linear, but what we're wondering is it proportional or non-proportional? Would it go through the origin? Would it be a 0, 0 if we worked our way backwards and went to 0 and then 0. So I'm actually going to get my calculator ready on this one because they look like numbers that I may not be able to calculate straight in my head. All right, so we have, this is our x value and this is our y. So from change of y, from 1,690 to 3,315, what's the difference there? What's the change? So in order to find it out, I'm going to subtract 3,315 minus 1,690. That is a change of 1,625. All right, on the left, the change in y's, or sorry, x's, is the difference from 130 to 255. So let's see what that is. 130 minus, oops, sorry, got to subtract the bigger number first. 255 minus 130 is 125. All right, and if I put that into a fraction, remember your y's always go on top of your x's, so 1625 over 125. Let's see what that would simplify to. Let's see if it comes out to be an even number. So 1625 divided by 125 is 13. So it's a whole number 13. All right, let's check the next one. From 3315 to 6565, that is a difference of, is that right? 565 minus 3315. Okay, yeah, it was. So that is a difference of 3,250. All right, on the other side, from 255 to 505, that is a change of how much? So 505 minus 255 is 250. So let's put those into a fraction. 3250 y divided by x, change in y's over change in x's. 3250 over 250 is 13. So it looks like our rate of change is constant and it is 13. All right. So let's go back up and read this sentence that probably didn't make sense to you at the time that you read it. A linear relationship is represented by a table is proportional when the quotient, and that means dividing, when the quotient of each pair of numbers is constant. When we divided these two numbers, we got 13. When we divided these two numbers, we got 13. So it was constant from one divided quotient to the next in the entire table. So this represents a proportional relationship. I'm just going to circle proportional for right now because I'm kind of out of space. All right, I want you guys to try the your turn at the bottom, and then go ahead and just push play again after you've given it a try. Okay, let's see what you guys got. The change from here to here was 60 per 6. 60 divided by 6 is 10. And the change from here to here was 60 per 6 again. So 60 per 6 meant 10 again. So this one was proportional. All right, in the next table, from 1 to 8, it's 7. And from 5 to 40, it's 35. So far, we have a fraction of 7/35. And you could divide that out and get like 1/5, or actually we can go ahead and do that. All right, the next one is from 8 to 13, that's 5. Per 40 to 65 is a change of 25. So 5 per 25. If I simplify that, that is also going to be 1/5. So once again, even though these numbers seemed weird and all over the place, this one was another example of a proportional relationship. All right. The very last section is comparing proportional and non-proportional situations. So you can use what you've learned about proportional and non-proportional relationships to compare similar real-world situations that are given using different representations. So we could only fit example 1 on the bottom here, and then we'll go on to example 2 on our last page of notes. So example 1, a laser tag league has the choice of 2 arenas for a tournament. In both cases, X is the number of hours and Y is the total charge. Compare and contrast these two situations. So here's arena A, it's just Y equals 225X. And here's arena B, and it's got a graph here. So let's compare these. In arena A, it looks to me like since X is the number of hours and Y is the total charge, so it's the total cost, it looks like to me it's $225 per hour. So you just go in and you play as many hours as you want, and every hour that you are there, you're charged an additional $225. Let's look at Arena B. Arena B looks like it starts at, these must be going up by 50. So it looks like our y-intercept is 50. I'm just going to write that off to the side. The y-intercept, which is your B, is 50. And let's find what the slope is. Looks like every 50 more dollars per, what would that be, a quarter of an hour? That's going to be a little bit hard for me to calculate. I'm going to go over to 1 hour. So it looks like from here to here, we've increased 100, 200 per hour. So if our slope is $200, I think it's rise over run would be 200 per 1 hour. So our slope is 200 per 1, or just 200. So in Arena A, you're charged $225 per hour. In Arena B, you're only charged $200 per hour, but you're going to start at $50 just to, it looks like maybe just to rent the place. Okay, so basically, in comparing and contrasting, I would say, and don't forget, if we want to go ahead and write an equation, I could make it look like this. So here's our one equation, and here's our, well, they already had your other equation. Okay, so it looks like the difference just depends on how many hours you want to rent the arena. When we're talking about comparing and contrasting, I would say something about the slope and the y-intercept. So slope on Arena A is bigger. So what we're saying there is it's more expensive because it's $225. But so the slope on Arena A is bigger, but it has no upfront cost. And then I would say something like the slope or cost on Arena B is less, so it's a little bit cheaper, but you pay, looks like $50 up front just to maybe rent the place. Okay, let's go ahead now and look at our last situation. So turn the page. We are looking at example 2 of our real world situation. Jessica is remodeling and has the choice of 2 painters. In both cases, X is the number of hours and Y is the total charge. Compare and contrast these two situations. Okay, so $45 per hour worked for painter A. For painter B, it looks like that is a change of $35 per one. So $35 per hour. Yeah, $35 per hour, $35 more per other hour. So the slope in this one is $35 per hour, but the y-intercept in this case, when x is 0, the y-intercept is 20. So this equation would be y equals 35x plus 20. So to compare and contrast, painter B is cheaper but has an upfront cost of $20. Painter A is more expensive but has no upfront cost. So again, it would just depend on how many hours you think that you need this paint. painter to work for you, which depending on which would be the better deal. All right, try the Your Turn. This is a situation with a test prep center. Maybe you guys are getting ready to take your ACTs and you are looking at whether you should go to Test Prep Center A or Test Prep Center B. So compare them and contrast them, but basically tell kind of like we did in the painting situation or in the situation just before this that had to do with the laser tag arenas, and then turn your video back on and check. Okay, this one was a little tricky because over in Test Prep Center B, you're reducing the cost, and so that would be subtracting an upfront amount. So not sure if you guys kind of caught on to that, but we'll see. For Test Prep Center A, the cost is $20 per hour. So the total cost equals $20 per hour. So our slope would be 20. Test Prep Center B charges $25 per hour, so that would be your slope, 25x. But you have a $100 coupon that you can use to reduce the cost. So this equation would be that the total cost equals $25 per hour minus a $100 coupon that you end up having. So to compare, Test Prep Center B is more expensive because they have a slope of 25, whereas A has a slope of only 20. So B is more expensive per hour, but since you have a $100 coupon, you get to subtract $100 off of that. So it is actually free for up to how many hours? If it's $25 per hour and you have $100 off, then that means it is going to be free for up to 4 hours. So if you had to go more than 4 hours, this might still be your better rate because then it's only $25. Whereas if you went more than 4 hours here, it'd be 20, 40, 60, 80. It'd be up to 100 already. So this is a really important skill to be able to find the slope and the y-intercept of everything and to know whether it's a proportional relationship or a non-proportional relationship. Remember, if it's a proportional relationship, there will be no y-intercept, no upfront cost. If it is non-proportional relationship, there will be some y-intercept or some term that represents b. Okay, go try some work on your own now.